Hello friends, welcome to Ansys-Tutor. In this tutorial, we are going to analyze natural convection in a cylindrical channel which have a stacked metal foam inserts in it. This is a cylinder which having 5 numbers of metal foam inserts at the bottom side. Those are heated, and at the top the metal inserts are at a normal atmospheric temperature of 300 Kelvin. The space between them is filled with air. We need to analyze what would be the effect of natural convection and heat transfer in between these metal foam inserts arrangements. So let's start. We are going to create the geometry in ANSYS Design Modeler. Change the units to millimeter. We are going to select the XY plane to draw these two circles. Draw two concentric circles. Now put dimensions over here. Put the outer diameter as 100. As the height of this metal insert is 20 mm. So you are keeping inner diameter as 60. So the thickness should be 20 over here. Now draw a polyline on this x axis. Right click and select open end. Now go to modify toolbar and trim out the upper half of the circles along with this polyline. Now we are going to extrude this one up to 10 mm. Select extrude option, click on apply, then select add frozen option, then put the depth as 10 mm. Now click on generate. This is our insert geometry. Now we are going to pattern this insert up to 4 copies, so that total there would be 5 numbers of inserts at the bottom end. Select pattern tool, select the geometry and select the direction as Z axis. Now put the offset distance as 90 mm, the number of copies as 4, then click on generate. These are 5 inserts. These 5 inserts will be used as heat source. Now we are going to insert another sketch. We are going to draw the circle to create the cylinder, which would be used as the outer air domain of around this insert. Now go to dimensions and put the dimensions of the cylinder. Diameter of 100 mm. Then click on generate. We are now going to extrude this sketch to make the cylinder. With add frozen option and the extent as, put the direction as asymmetric, so that the extrusion would be in both direction with the values provided. We are going to start this starting of this cylinder at 95 mm from this inserts. So we are keeping depth of 95 mm over here. Total length of this cylinder is 600 mm. So that these inserts should be at middle portion. Now select the XY plane and create another sketch. Now we are going to draw the upper inserts. Again select the circle tool and draw the 2 circles. This is the inner circle. Draw another circle. Now put the dimension. The inner diameter is 50 mm, the thickness is 20 mm of the inserts. So keeping the outer diameter as 90. Turn off this solids and the sketches so that we can draw properly on this plane. This is hide all this sketch and turn off this geometry. Now go to sketching and draw a polyline. Right click and select open end. Now trim out the bottom part. Now click on generate. Similarly, we are going to extrude this top inserts and doing the pattern. We are going to do the patterns of 4 numbers of copies, so that the total there would be 5 numbers of inserts. Select the extrude and put the depth of 10 mm. And click on generate. This is the top half of the insert. This is the add frozen option. Now we are going to pattern this up to 4 number of copies along the Z axis. Select the geometry and click on apply. Hide this outer geometry so that they will be easier to select. Now select the geometry, then click on apply. In the direction, select the Z axis, then click on apply. Now put the number of copies as 4, then click on generate. This is the pattern geometry. Pattern of this geometry that has been obtained, which is having 5 number of copies in total. Now we are going to create another circle at the center. Now there is no need of putting the dimension, that it has taken already the constants of the inner circle. Now extrude this inner circle up to the same length as the outer circle, creating the inner cylinder geometry. Put the first depth as 505 mm and second one is 75 mm. Then click on generate. Now this is our inner cylinder. Now we are going to subtract this inner cylinder from this outer cylinder, so that there would be space between, there will be hollow space in the cylinder. For this, go to create menu and select boolean option. Choose the subtract option. Select the target body as the outer cylinder and tool body as the inner cylinder. Then click on apply. Preserve tool body option as no, then click on generate. Now you can see there is a hollow. A hole has been generated in the cylinder. Similarly, we are going to subtract all these inserts from this outer cylinder. Go to create menu and select boolean tool. Select the boolean subtract, target body as the outer cylinder, the tool body as the inserts. Now hide the outer body and select all these inserts. Now preserve tool body option as yes. Then click on generate. A boolean has been completed. To check the boolean, you can hide all these inserts to see the markings on this fluid domain, on the groups on the fluid domain. By hiding this one, you can see these are the groups in this fluid domain. Now select all this and make it as new part. So that all this geometry will be grouped together. Now geometry is complete. Now proceed for meshing. Open the meshing workbench. Click on the mesh. Go to sizing and turn on the adaptive sizing option. Increase the resolution up to 7. Then right click on the mesh and click on generate mesh. The mesh has been generated. Hide the outer meshing to see the inner one. Now right click and show all these bodies. Now we are going to put the named selections to all the boundary surfaces. Select the face selection tool. Select the first end and second end of this cylinder. And name it as insulated 1 and insulated 2 respectively. Name it as insulated 1. Both ends of this domain is insulated. Similarly, put another end as insulated 2. Now select the volume selection tool. Select the outer air domain and name it as air domain. Hide the outer air domain. Select all these inserts at the bottom side and name it as heater source. Similarly, select the top 5 inserts. Right click and create name selection. Name it as for metal foam. Now select the insides of this cylinder, inside cylinder. Zoom in and select all the faces of this insert. There will be 5 numbers of these faces. Right click and create named selection. Name it as inner pipe. Click on OK. Similarly, put the name selection to the outer walls of this air domain. Right click and name it as outer pipe wall. Now name selection has been complete. Right click on the mesh and select update mesh. The mesh has been saved. Now proceed for Fluent solver setup. Open the setup workbench. Select the double precision model and click on start. Turn on the gravity. Put the gravity as negative y direction 9.81. Now go to models. Turn on the energy equation. Keep the viscous model as laminar. Now go to materials. Now change the density of the air from constant to incompressible ideal gas. Click on change, then close. Now we are going to add the metal foam, copper metal foam materials over here. Name it as copper metal foam. Click on change create. Click on no. Now another material has been added. Now put the density of the copper metal foam, that is 1344 kg per meter cube. Then specific heat and thermal conductivity. Click on change create, then close. The material has been added. Now we are going to assign this material to various cell zone conditions. Now go to cell zone conditions. Select the air domain. Now check if air has been assigned or not. Then apply, then close. Change the heater source from fluid to solid. Then assign the material over here. Select the source term, as the metal foam is going to produce heat over here. Select the energy source as 1 and put the heat flux value over here. Select the constant, heat flux of 1500 watt per meter square. Click on OK. Then apply, then close. In the upper metal foam, I will only assign the material as it is going to be at normal atmospheric temperature. Now go to boundary conditions. Filter out the boundaries as per their types. Select the insulated 1 and insulated 2 and put heat flux 0 over here at the two sides of the cylinder. Click on edit, put thermal tab and put heat flux as 0. Assign the material as copper foam, metal foam, and close. Similarly, another end, make it insulated. Now the inner pipe, assign the temperature of 300 Kelvin. So put temperature value, select the material, then apply and close. At the outer pipe, keep the temperature as 300 Kelvin. That is the default atmospheric temperature. Click on apply, then close. See the created default interior walls. That is the heat source. keep the temperature of 300 Kelvin, outer wall of the heat source. By default, coupled boundary condition has been assigned to these interior walls. Now go to methods. Select the simplex greenhouse cell waste method. Now go to monitors, select residuals, decrease the residuals of energy up to 20, 10 to the power minus 20, so that iteration will take more time and solution will be more accurate. Go to initialization, select the standard initialization and click on initialize. Now go to run calculation page, put the number of iteration as 300, then click on calculate. The iteration process has been started, it will take some time. Calculation is complete. Close the Fluent solver and proceed for CFD post processing. Insert a new plane. Select the ZX plane at y is equal to 0. Create another plane vertically on the YZ plane with x is equal to 0. Now insert a contour. Select the two planes. Select the variable. Select velocity. Increase the number of contours, then click on apply. You can see the velocity variations in this domain. You can also modify this legend view bar. Let's see temperature variations. These two temperature variations. Now we are going to create another plane. Select the XY plane. Z is equal to 100, so that it will be at mid of a insert. Now insert a contour. Select the location as plane 3. Select the temperature as the variable and number of contours as 100. Now this is the temperature variations. Due to the heat source, the temperature is maximum at the bottom side. The space between these two insert the air domain. The temperature variations due to natural convection. Now if you are moving this plane apart from away from this insert, we can see the variations. And this is the velocity variations with maximum temperature at the bottom side. Now we are going to see variations of temperature around these inserts. So select the heat source. Select the variable as temperature, then click on number of contours, then apply. These are temperature variations on this insert. Similarly, see the temperatures of the top half of this insert as it is at normal atmospheric temperature. With this, let's conclude this demonstration. If you have liked this video, then hit the like button. Subscribe to our channel if you are new. Keep learning and keep exploring and get new ideas every day. Thank you.